Okay, guys, so we're going to keep going with factoring. Now, we did factor in the last unit with quadratics, but that was only ever a squared polynomial. So now in this unit, we're getting into the third power or fourth power polynomials. So up at the top, those are the ones that we've already looked at. So the general squared trinomial, sometimes you guys could break it up into two parentheses. Sometimes it may have been a perfect square or a difference of two squares, where you could write it as x plus 4 squared instead of x plus 4 or x plus 4. Or if it was a difference of two squares, one had a plus, one had a minus, it was the square root of both your numbers. And then the other one we discussed briefly was the common monomial, where you guys had to pull something out and then say, okay, we're left with 2x plus 5. So we're saying, what was that highest or greatest factor that could go into both of those? So today, we're going to look at a third one, and that's going to be difference in sum of cubes. But we have to know, guys, when something is factored completely. So the definition says that something is factored completely if it is written as a product of unfactorable polynomials with integer coefficients. So nothing else can be pulled out. Everything has been as separated as it can be. So for instance, 2 times x plus 1 times x minus 4 and 5x squared times x squared minus 3 are both factored completely because you can't do anything else with the x plus 1 or the x minus 4. But if you move down here, this x squared minus 4, yes, we did pull that 3x out. Yes, that is a factor, but we can take that x squared minus 4 further. That x squared minus 4 is a difference of squares and can be broken down into x plus and x minus 2. So it would be written as 3x on the outside, your x plus 2, and your x minus 2. You have to know, guys, if you can break that down further. So we're going to go ahead and look at the sum or the difference of two cubes instead of squares. So the sum of two cubes says that if you have two values that have both been cubed with a plus in the middle, it's going to come out in this form of the first cube of the first plus the cube of the second, or cubed root, I'm sorry, and then the first one squared minus them multiplied together plus the second one squared. Looks a little crazy, but if you remember the rule, it won't be too bad. So like here, 8x cubed plus 27. 8 is a perfect cube, 27 is a perfect cube. What are the cube roots of those values? Well, the cube root of 8x cubed is 2x, cube root of 27 is 3. So 2x and 3, 2x squared, 3 squared, 2x times 3. Multiply them together. The difference of two cubes is the same way. The only thing that changes here are your signs. So for a sum, the first sign is a plus, the second is a minus. And for a difference, the first one is a minus, the second one is a plus. So there is an acronym, guys, here that helps to remember the rule. And that acronym is SOAP. And it stands for same sign, opposite sign. Oops, that's a little rough. Always positive or always plus. Let's do plus. So say you were given, so two perfect cubes. So two perfect cubes could be 125 and 8. And the x has to also be cubed, guys. So we're always going to need to start with our two sets of parentheses. So same sign, opposite sign, always plus. So same sign. Whoops. So it's the same sign, so we're going to keep the minus. Then it's the opposite sign. So opposite of a minus would be a plus, always positive. So when we're doing this, we need to take the cubed root of both of these values. So what's the cubed root of 125? X cubed? 5x. What's the cubed root of 8? 2. Okay, now that we've found those two terms, 5x and 2 are our a and b. So 5x and 2, we need to square the two terms. So the first term is 5x. What is 5x squared? 25. X squared. What is your second term? 2. What is 2 squared? 4. In the middle, you want to multiply terms together. So if your terms are 5x and 2, what is 5x times 2? 10x. So that's how you factor. And you can't factor that 25x squared plus 10x plus 4 any further. So that's your acronym. And as long as you have two perfect cubes, you should always be able to do this using your SOAP and using these keys here. So taking the cubed root, finding those two terms, then squaring them, multiply them together. Okay, let's flip to the next page.